Changes in our surroundings. Lesson preview. Types of changes. Reversible and irreversible changes. Physical and chemical changes. Changes when different substances are mixed. Some more examples of physical and chemical changes. A number of changes take place around us all the time. These changes take place on their own. You must have seen trees shedding their leaves, new leaves coming out, fruits ripening, and flowers blooming. The weather changes and so does the day into night, and vice versa. You also notice change in your body when you grow taller and your hair grow longer. Every change has a cause. The cause brings about changes in shape, size, position, color, state or internal structure of things. Shape. When you squeeze an inflated balloon, its shape changes. Size. Plants grow taller, babies grow into children, and then into adults. Position. When you strike a ball with a bat, it moves from its position. Color. When onions are fried in oil, they change color from white to brown. State. When you put water in freezer, it solidifies into ice. Heat water and it converts into vapor. Internal structure. When we cook food, its molecular structure changes. Burning wax also causes change in wax molecules. New substances are formed in both the cases. Types of changes. Just as chemists have classified elements and compounds, they have also classified types of changes. They learn a lot about the nature of matter by studying the changes that matter can undergo. Reversible and irreversible changes. Activity 1. Blow air into a balloon. It will change its size and shape. Now release the air from it. The balloon will get back to its original shape and size. Activity 2. Take a ball and roll it. Its position shifts. You can pick up the ball and place it again in its original place. Activity 3. Take a piece of paper. Fold it to make a paper boat out of it. The shape of the paper has changed. Now, unfold the paper to bring it to its original shape. In each of the above activities, we are able to bring back the material to its original shape and position. All the three changes in the above activities can be reversed. They are known as reversible changes. Activity. Blow a balloon. Now burst it by pricking with a needle. Activity. Take a pencil and a sharpener. Now as you sharpen the pencil, it becomes smaller in size. The above changes are irreversible changes. In these changes, however, there is no change in the internal structure. Activity 6. State whether the following changes can be reversed or not. Table 6.1. Change. Can be reversed. Yes, no. 1. Dough to chapati. 2. Cold milk to hot milk. 3. Raw egg to boiled egg. 4. Bread to toast. 5. Raw fruit to ripe fruit. 6. Cream to butter. 7. Wool to sweater. Physical and chemical changes. Another way of classifying changes is based on whether new substances are formed during the change or not. Based on this, changes are of two types, physical changes and chemical changes. Physical change. In a physical change, the substance changes its form, but does not change its chemical composition. No new substances are formed. The molecules of the substance remain exactly the same as before. Examples are 1. Kicking a ball. When we kick a ball, only the position changes. The molecules which make up the ball remain unchanged. Sharpening a pencil. The size of the pencil changes on sharpening. However, no new substance is formed. 3. Drying wet clothes. Here again, no new substance is formed. Freezing water. When we freeze water, we get ice. When we melt this ice, we get water. The molecules of water and ice remain the same. Heating iron or liquids. When we heat a piece of iron, it expands. Liquids also expand on heating. This is called expansion. On cooling, both substances return to their original size. This is called contraction. Water is an exception to this rule, as it contracts on heating and expands on cooling. Reversibility of physical changes. Most physical changes are temporary, which can be easily reversed. However, some physical changes like sharpening a pencil, cutting of vegetables, etc., cannot be reversed. Usefulness of the property of expansion and contraction. All the tools shown have an iron ring which fits into a wooden handle. The ring is usually slightly smaller in size than the wooden handle. When the iron ring is heated, it expands in size and can be easily fitted on the handle. On cooling, the iron ring contracts and fits tightly on the handle. Similarly, this property is also used to fix a metal rim on a wooden wheel of a cart. The metal rim is slightly smaller in size. It is heated so that it may be expanded to fit on the wheel. Cold water is poured on it to cool it. It contracts on cooling and fits tightly on the wheel. Metal bridges and railway tracks have small gaps, known as expansion gaps, between metal parts. These gaps allow for expansion during hot weather and prevent damage to these structures. Chemical change. In a chemical change, the substance changes its form with change in its chemical composition. As a result, a new substance is formed. Burning. What happens when you burn a piece of paper? Smoke and gas like carbon dioxide and water vapor are given out, and ash is left behind. The molecules of ash are different from those of paper. Thus, a new substance is formed. It is an irreversible change. Cooking. When your mother makes chapatis, a new substance is formed. The molecules of chapati are different from those of dough from which it is made. Similarly, when a cake is baked and rice or vegetables are cooked, new substances are formed. A chemical change takes place when there is a chemical reaction between the substances. Most chemical changes are permanent and irreversible. In a chemical reaction, the original substances present are called reactants. The new substances formed during or after the chemical reaction are called products. Activity. Measure the length of a candle and light it. Let it burn for 10 minutes. Blow out the candle and measure its length again. It will be seen that the candle becomes shorter and wax drips from the side. This is because on burning, wax reacts with air to form water vapor and carbon dioxide. It is an irreversible chemical change as carbon dioxide and water vapor cannot be converted back into wax. The melting of wax is a physical change. Thus, wax undergoes both chemical and physical changes when a candle burns. Changes when different substances are mixed. We have seen that when sugar is mixed with water, it dissolves to form a solution. We have already studied that we can get back the sugar from the solution by evaporation. Thus, the change is reversible. It is a physical change as molecules of sugar and molecules of water do not undergo any change. Activity. Take lukewarm milk in a bowl. Put a tablespoon of curd in it. Cover the bowl and leave it undisturbed for about 5-6 hours. You will see that curd has set. Do you think this change can be reversed? The setting of milk to form curd is an irreversible chemical change. Thus, we see that heating and mixing of substances bring about a change. Some of the changes are reversible and some are irreversible. Mixing of substances can bring about both reversible and irreversible changes. Mixing of salt and water results in the salt dissolving in water completely to form a solution. Now, we have seen earlier that salt and water can be separated by evaporation. No new substances are formed and the change is reversible. When washing soda is mixed with some lemon juice, bubbles of carbon dioxide are produced. You can prove that gas so released is carbon dioxide since when you bring a lighted matchstick near the reaction vessel, its flame is extinguished. Here, a chemical reaction has taken place between the two reactants, washing soda and lemon juice. Carbon dioxide is one of the products. Other products are also formed. This chemical reaction can be represented as follows. Washing soda plus lemon juice, carbon dioxide plus other products. Mixing of substances can thus produce both physical or chemical changes, depending on the nature of substances mixed as also on the conditions under which the substances are mixed. For instance, if iron and sulfur are mixed, no chemical change occurs. But if this mixture is heated, it glows after some time and a black substance is formed which is a completely different substance having entirely different properties from those of iron and sulfur. Hence, heating a mixture of iron and sulfur produces a chemical change. Cooking of food is yet another example where heating produces a chemical change. Some more examples of physical and chemical changes. Boiling, evaporation, and condensation. When a liquid is heated, its molecules begin to move faster, escaping from the liquid in the form of gas. However, when this gas is cooled, the liquid is obtained again in its original form. Hence, boiling, evaporation, and condensation cause physical changes which may be reversible. Rusting. When an iron rod or chain is kept in humid air for some days, a layer of brownish substance gets deposited on it. This slowly eats up, corrodes, the iron. It is seen that this substance called rust has very different properties from those of iron. There is no simple way of getting back iron from rust. What kind of change is rusting of iron then? Rusting is an example of a chemical change.